Arthur Conan Doyle's iconic character Sherlock Holmes once famously said, "It is a capital mistake to theorize before one has data." And here at Lokad, we'd certainly agree with that, as data is the foundations of any optimization project we embark upon. So today, we're going to discuss if a company already collects data, what they can do to improve, and tackle the myth that data needs to be perfect for machines to work with it. So Johannes, if a company is already collecting data, is there that much more that they can actually do?
Yes, I mean, the first thing to understand is that most companies collect data, but in a completely accidental way. It was never the intent was never to collect data, but just to operate. You know, that's also this big myth. For example, an ERP is not designed to collect data. It's designed so that all the very mundane operations that are happening all the time in the company can happen with the support of a centralized IT systems. Just like when you are at the point of sale in a store, the electronic, cash register is just there to get your payment faster. It's not the system was not actually engineered or put in place for the purpose of collecting, a full transactional history of all the receipts. And because those systems, plenty of systems have been, collecting data for ages, a bit incidentally, yes, companies do end up with a lot of data. But it's not necessarily, I mean, they can be, so there is a lot of data floating around, and usually over decades, over the last few decades, usually some sort of, forecasting process, optimization process emerge on top of that. But it doesn't mean that there is not, enormous, I would say, leeway for improvements.
Okay, so if they weren't kind of meaning to collect data when they first kind of set out, does that mean there's entire kind of troves of data which is just kind of left somewhere in storage and it hasn't really been thought about?
The problem is usually, again, data is not reality. It's just an artifact as a byproduct of your transactional systems. So it's not exactly messy. It's just when you look at the data as it is generated in typical corporate systems, it's something very alien. It's not mimicking the reality at all. Usually it has more to do with just the inner plumbing of the IT system than with the reality of the process. And as a result, when people, a large organization starts, let's say, I don't know, an s&op process, and they want to have some kind of forecasting in place, just very classical stuff where you want to look ahead so that you know what you're going to produce or buy, to basically prepare how to serve better, the demand. We are talking about companies having like flows of physical goods. They end up with the situation that the data as it exists in those, I would say, company systems, all those layers of software that just help the company to operate, the data is just very, very strange and alien and has tons of accidental complexities that have nothing to do with the forecasting challenge or whatever. And so typically, what companies do, most of them, especially when we start working with them, usually this process is already in place. They have already put in place something that is kind of extracting a very simplified version of this data. And so they end up with daily sales, for example, weekly sales, these sort of things. And then they build their forecast on top of that. And that's where I would say there is a whole range of issues, which is the fact that this data, once it has been extracted, as daily sales or weekly sales, usually a lot of very critical information are lost. And it's a very, very lossy transformation. It looks simple, it looks reasonable, but actually you've lost massive amount of information about what is going on in the business when you do that.
But sort of how granular does that data need to be? Because I mean, if we're looking at a company that's been collecting data for sort of 20 odd years, surely aggregating that data makes things a lot more easy to manage.
Absolutely. I mean, when you aggregate data, you end up having, so you basically typically you reformat the data so that it nicely fit into something that typically works with, let's say, time series. And yes, time series, it's super nice. You know, one number per day. It's just like that. So you have like a series, one number per day, and then you want to project that into the future. It's very simple. There is plenty of super naive models that works. I mean, when it says that works, that can operate on this type of data, starting from moving average. You can have something a bit more fancy. But the problem is that it's not because it's easy that it's actually relevant. And that's the problem, is that yes, it is very easy to do it that way. Doesn't mean that it's actually it has any relevance for the company, and that's the danger. It's not just the problem is that people think, oh, I need more disaggregated data, so I go from monthly data to weekly data, or I go to weekly data to daily data. That's just changing the time frame of the aggregation. And they would say, oh, if we do it better, we'd go to hourly data. I say, That's absolutely not the problem. The problem is that when you think of, I would say, time series data, this is already an artifact. This is already a way to frame the problem in a way that is completely different from how the data actually exist in your systems. In your systems, there is no such thing as time series. But what matters is to have the data with a transaction granularity, because actually it can tell you a lot more. And if you want to have like better forecasts with better data, better here means, in our experience, better data really means to have something where you get very close to the way things are in your IT system, as opposed to have like a super dumbed down version where all the relevant information has been lost already.
Okay, so you say sort of the relevant information will be lost, so basically the data you're looking at could be slightly misleading. So what are the sort of scenarios that you might be missing out on?
I mean, usually it's things that are so mundane that people even forget about it. It's, for example, the fact that let's have a look at a retail chain, groceries. So imagine you have you have series of distribution centers. Each distribution center is serving, 20 supermarkets or something. And how does it look like, this sort of things? And you take the position of optimizing, let's say, the stock in the distribution center. So what it looks like is that, let's say in our hypothetical, network, every single day stores pass orders to the distribution center. And then when you order, 100 units of something for the supermarket, two things can happen at the distribution center. Either the distribution center is able to fulfill the order, so there are just 100 units were ordered, and they ship 100 units typically the next day or something. Okay, all is well. Or they might actually not fulfill the order. So the store pass an order of 100 units, and then the distribution center do not fulfill, so they don't send anything. And then the next day, the same store pass another order of 150 units. Now the question is, if you want to acknowledge what was the demand at the distribution center level for those 2 days, was the demand like 100 units plus 150 units? But that feels wrong, because you see, the reason why on the second day the store is passing an order at 150 units, it's because they were not, the order the previous day at 100 units was not fulfilled. So basically they had to cover both the demand for the day that was not fulfilled plus another day. So then you end up ordering more. But it's a mistake to think that the demand is now the total demand has been 250 units. Maybe actually the total demand is just 150 units, because and then you should be discarding entirely things. But the reality can be messy. Maybe they lost some sales, so maybe you should not discard all of the 100 units. And again, the thing is, as soon as you start producing a time series, this information is lost. And all the ambiguity that were existing, because there is a lot of ambiguities, all those ambiguities are eliminated. And you could say, oh, it's a good thing. Suddenly I can have my data scientist that works on non-ambiguous data. Yes and no, because you see, by removing the ambiguity, the problem is that you've already made a statement about how your business operates, works, and what is in your business. And the problem is that this statement can be super wrong.
And obviously, one of the reasons companies kind of aggregate their old data is because they might be moving from one ERP system to something newer. So is it really useful to have all of that historical information maybe re-imported into the new ERP system?
I think historically, again, when I was saying, things that we nowadays call ERPs, transactional layers of systems that just manage routine operations, their goal was not to collect historical data. And thus, when it all started, you'd say late 70s, 80s, preserving data was not, a goal. And at the time, it was just to basically let the company operate more smoothly. And due to the fact that at the time, computing hardware was very, very expensive, compared to present time, and especially that data storage was also very, very expensive, a lot of software vendors did the right thing at the time. They implemented tons of heuristics to basically get rid of all data in many, many ways. And I'm not talking, and nowadays, most of those heuristics or most of those systems just don't make any sense anymore, just because data storage is super, super cheap. So I think, again, the idea is that indeed there was a lot of bad practice where things were just ditched. But usually, nowadays, it's not even that the problem. Frequently, even when companies change of system, etc., the data is still around just because it's very cheap. You just have like a legacy database that contains tons of things. But again, the problem is usually that many companies look at, when we start, typically when Lokad starts with companies of certain sizes, they usually have already a forecasting process in place. And those companies are very, very surprised when basically we say, we have a close look at that and we say, well, we're not going to even use that as a starting point. It's like, this is not even a starting point, this is like nothing. And why? Because if we look at the system, what do we see? We see something that is like a very crude projection of this enormous trove of transactional data into a super dumb subset of time series, and we say, well, all the relevant information has been lost in this projection, so it's not a good starting point. And the goal is certainly not to use those very weak time series that you have somewhere as a starting point to optimize the supply chain.
So with that example, is there anywhere that these companies should be doing sort of data cleansing, or are you saying they should just take their raw data and leave it?
No, data is already clean. Again, that's the problem. It's you see, when you say data cleansing, what does it mean? If I tell you the problem is that you want to have like a good, accurate picture of the world, and for some reason you decide that the way you're going to look at the world is only to look at things in terms of shade of green, and so you have a picture that only takes shade of green. Anything that is like not green, it's just going to be black, so you're not going to see it at all. And then things that are more or less green, you're going to have like not shade of gray, but shade of green, okay? And that's your picture of the world. So obviously, and then you would say, I think I need to do some data cleansing. This picture is not very accurate. I need to maybe kind of improve it. I say, you need full spectrum of colors. The problem is not that shade of green. You need to cleanse that. There is no cleansing. Your picture is just what it is. It's so again, the problem is just if you want to have like better data for better forecast, first thing is just start to look at the company as it really is. And it's not data is not incorrect. It's just wrong. It's just the way it is. And when I say adjust the way it is that, again, producing data was never the first objective of all your systems. Your systems have been put in place so that the supply chain can operate, so that it's possible to produce, so that it's possible to move stock around, so that it's possible to sell it. So all the data that you have is just a reflection of all those processes, which is just fine. And the fact that it works and you have like things like invoices, payments and whatnot, prove that basically this data is largely correct Otherwise, you would not know what to invoice. You would not know how much to pay your suppliers and whatnot. So I think usually for most companies nowadays, at least companies that have been using computer systems for decades, as is the case in basically in Europe, in North America, and actually in most of Asia at present time. It's already in place, it's already solid, so it's not the problem. The problem is that when you think in terms of forecasting in terms of simplistic terms, it's not just about sales, it can be about returns. It can be also just, for example, one of the super basic things when people think of what can we do to basically improve our forecast. Usually when we start looking at those time series, we say, you know what, you don't even know the price. Usually when we start working with companies and they want to improve their forecast, we just look at their data pipeline that is generating the forecast, and we see that pricing is absent. So basically, obviously prices have a massive impact on supply chain. If suddenly you discount all your products by 50%, your demand is going to explode. Maybe your profitability is just going to vanish as well. But nonetheless, prices usually have a massive impact on demand and on your supply chain. And most of the time, when we look at those S&op processes and forecasting processes, pricing are absent. But it's not, it's usually the tip of the iceberg.
Yeah, we've kind of touched upon it before, that people kind of have this focus upon demand. Pricing is obviously one thing that they can look at, but maybe perhaps it's worth reiterating what are the other kind of things that might be of interest.
Usually returns are absent, stock levels are absent. And you would think, why do you need like stock levels? And the answer is, well, because first, if you have a stock out, then you're not going to sell anything just because there is nothing to sell. Or maybe you will get back orders. But again, it's a very specific pattern. So can you really count a back order like a regular, sales? It takes commitment. A back order is basically the product is not there, so I'm going to ask the vendor to basically put something on the back order to have it shipped later on, and as a client, I'm willing to have maybe an extensive delay. So again, this is demand, but it's demand that is not exactly of the same nature compared to regular demand. So if you just say 1 unit of back order is just exactly the same that 1 unit of sales, not really. Especially just to give you an example, if for some reason it just happened that a large portion of the demand that you have maybe that happen in B2B, that are clients that are okay with back orders and long fulfillment delays, if they can get a better price, then suddenly from a forecasting perspective, it's very, very nice, because suddenly you don't have to forecast anything. You just see the back orders and you just orchestrate your supply chain so that when the expected delivery time comes, you have the stuff ready. But you don't necessarily need to forecast this demand, because this demand, is known in advance because it's already ordered.
If you want to make the most of the data that you currently have, what's your kind of advice then to companies? What can they do to build upon that raw data?
The first thing is that you need to take the problem from, I would say from a very domain-specific perspective. You need to ask yourself, I have a supply chain, what really matters? And the answer really depends on the type of supply chain that you operate. If you're in aerospace, the question really boils down to, we are talking about spare parts for, to keep the aircraft flying. The question usually boils down to, for every dollar that I invest in my supply chain, how can I avoid the maximum number of AOG, aircraft on ground incident, because there is something missing and you have an aircraft that is stuck on the ground. So usually the question is, how can I get, the maximum amount of AOG incidents solved per dollar invested? That would be, the perspective, for aerospace. Obviously for fresh food, that's going to be a completely different problem. That would be, okay, I have stores, how can I, really maximize the long-term loyalty of my clients, because it's all about repeat business. So what you want is it's not the service level of one single product is kind of pointless. You don't really care about that because there is so many substitutes. What you want to make sure is that your loyal clients who are coming to your store to basically buy not one product but a whole basket have a very good experience. And so if there is something missing, there is always substitute, and that they can walk away from your stores very satisfied with not only the overall availability but the overall freshness of what they're buying. So that will be part of the whole experience. And again, the question it will be per dollar invested. How can you optimize that? The question is really domain specific. What are the data that are the most relevant, where you need to really pay attention? Well, it's only your domain expertise that lets you be a judge of that. And usually it's not. It doesn't require advanced data science skills. It's just I would say direct understanding of the domain that lets you tell if something is like nice to have or completely critical to avoid making like super dumb decision.
Okay, if we start sort of wrapping things up then, what's kind of the core message of today? Is it basically that with your historical information, it's not worth trying to perfect that and trying to aggregate it. It's all about accepting that perhaps there's all of this history and trying to work with that instead of trying to make it sort of easier to work with?
So if we take the goal of this episode, it's how can I have better forecasts with better data? That would be to something that's what we want to have. And the better data is typically not what you expect. I mean, you can have data that is much, much better for your forecasting undertaking. But the problem is, what do I mean by better? And usually the Lokad experience is that we mean very specific things that are absolutely not what most people expect. First, better data is first to have a complete picture of all the things you should be looking at. And usually it's not data like Instagram or social networks, weather forecast. It's something that is much more mundane, things that already exist in the system. It's something where you have, many people, maybe people before you, have already decided they were not even worth looking at. Well, our message is those data are very much worth looking at. I'm talking about pricing, returns, back orders, stock movements, all of that, they do matter. So, and your good news, these data are already present somewhere in your systems. So first, expand your horizon on what you even consider as relevant data. And then forget about this. The second thing would be forget about this idea of data preparation or whatnot. Now, you need to have understanding on how the data is generated. Why? Because otherwise you're going to end up with a garbage in, garbage out situation. And understanding the situation, the data is tricky because it's two things. It's understanding the software, but also understanding the process followed by people that are operating on top of the software. So usually the semantic of the data has two parts. It's half in the head of the person who operates the software and half in the head of basically the software engineer who designed the enterprise software in the first place. And obviously when I say the person actually, unfortunately, usually it's many, many people. And the worst case is when those people have conflicting interpretations, and that's where you can have like very messy situations. So you see, so expand your horizon in terms of relevant data. Nothing very fancy, just very basic, mundane things for your business, but just not just sales. And then you need to have like understanding of this data. And finally is if you want to have like better forecasts, we comes to what does that mean, better forecast? And then we go to the point where people would say, oh, it's better mean absolute percentage error, better mean absolute error, better, all sort of like metrics. And again, I would say, if it's expressed in percents, it's just not good. It needs to be expressed in dollars. And just like we discussed in one of the previous episodes about decision first, ultimately, a forecast can only be deemed better if it leads you to better decisions. So unfortunately, the way you can judge if a forecast is better or not is through the prism of the final decision that you take. So it's difficult, but this is the way you do it. If you just say, oh, I have a better maybe, and the forecast is better, no, that's very, very wrong. And you're not even going to be, you're going to be on a path where you end up with, I would say, making things that are mistakes of naive rationalism mistakes, sort of. Yeah.
Okay, we'll have to leave it there, but I'm guessing there's probably a few IT managers that aren't going to thank us for this because they're going to be scrabbling around the archives now. Okay, that's everything for this week. Thanks very much for tuning in, and we'll see you again in the next episode. Bye for now.